Can you hear me?
Yeah, we are already in.
Yes.
So everybody's in? Okay, is Alan there?
I'm here.
Okay. I guess we can start. So, okay. So, welcome to the last session. We call this a panel discussion. We're going to go over all the Q&A that was generated through all the talks. And after that, we're going to make some observations and hopefully you'll find them interesting. And we need your feedback on some of these as well to promote some nice discussions here if we can. Okay, so I'm going to go over the Q&A. I'm going to share my screen. Let's see which one it is. Okay. So now I can't see anything except my screen, I guess. Okay, so we're going to do Q&A. So the first question is from is to Alan Hevner from Pascal Hitzler, and it says, "Thank you for the very stimulating presentation. What is the best resource to start reading up on design science research in more detail?"
Okay, well, as I told Pascal, the references in my presentation, I think, are the best place to start. I think on slide 4 or 5, I had listed 3 of, if you will, the seminal papers to include the 2004, 2013 MISQ papers, and then there's a Journal of the AIS paper. So I've shared my slide deck with Frederick, and I think he's going to post that on the conference website. So feel free to take a look at those papers. If you're having difficulty getting copies of them, just let me know. Be happy to send you copies of those papers.
It seems when I'm sharing my slides, I can't see the participant list. Is that the way it's supposed to be? But so, oh, I see. Okay. Well, I don't know. All right. Question number 2 to Alan as well, from Engelbert Mefu Nguifo. How do you integrate explainability and ethical issues in design science research?
Well, that's a very good question. It's a very complex question. We could discuss that for a long time.
I'm sure.
You know, the idea of ethical design is very important. I think anytime you decide to, you know, implement a particular design, you're advantaging some people, you're disadvantaging other stakeholders. So I think any good design process needs to have a way to, first of all, explain your search process for the best design that you did generate and decide to implement. But then once the design comes into play, once it starts having emergent values and capabilities, I think you need to monitor your design as it's being used, and you know, the feedback loop from how the design is being used and its emergent properties will allow you then in your next cycle of design to, you know, achieve maybe more ethical and also provide maybe better explanation. Of course, we know AI and data analytics is big on systems being explainable and being transparent. So that needs to be part of your design process as you go forward.
Yeah, so it's got to be there. Your approach is actually a meta approach to building things. And if you build them without this, they don't have it. If you build them with it, they have it. So that's Frederick, is this person in the room at all? Frederick?
Yeah, I'm here.
Yeah.
Yes.
Okay, does he want to add anything to this or anything? You want to unmute him and maybe ask him?
Yes. Yes, please, Anselberg.
Hello, sorry.
Yes, oui, oui.
I didn't understand. I was. I'm sorry.
Can you add any additional comments or question?
No, no, it's okay. It's okay for me. Thank you.
Okay, okay. All right. So let's go on to the next one. Is Jushan Kalra in the room? I think he is.
Yeah, I'm right here.
Okay, good. So this is from a fellow named Robert Dani. Says, when was the USDA data set of nutritional information updated, as ingredients have probably changed over time?
Yeah, so it gets updated pretty regularly. The latest one is of 2018, July 2018, if I'm not mistaken. And that is the data set that we used. Even though it is getting updated regularly, it still contains only the ingredients present in United States and not other countries. So that provides a little gap between the ingredients that we are using and the ingredients that we have in our database. So that's a problem, but yeah, So basically, yeah. So 2018 was the year that it was published.
Okay.
Yeah.
Thank you. Okay, so another question for Jushan from Wad Al-Hoshan. Thanks for the paper, looks very interesting. Have you considered weighting ingredient names with PMI?
Right. So what we wanted to do was compare two strings. So that one was the ingredients that we were getting from our recipes, and the other was from the nutrition database. So no, we did not consider Pointwise Mutual Information. We did not consider PMI for that. So we did not consider embeddings method in general, just because I'm not sure how relevant they would be for nouns, and I don't think that you would get very good results because of that. If you could provide a little more clarity, if the person who asked the question could provide a little more clarity on what particularly they wanted, because I read the question and I was a little confused about how they would use word2vec in this place for comparing two strings.
Well, they say deep learning. I've always said the word2vec is not deep learning, but it's not very deep usually. But so I don't know what he meant either. Is he part of the room?
He was initially, I think he's there.
I think it too.
Well, okay.
Yeah,
So what learning models besides word2vec, I guess?
Yeah, and anyways, I'll just answer his next questions if he's not available.
Is here. I can unmute him and see.
Yeah, he's here in the chat. He's Wad. I think I'm sorry if I'm mispronouncing your name. I'm really sorry, but I think Wad Al-Hosn. I'm not sure.
It seems like it doesn't allow him to unmute.
Oh, okay.
Okay.
But
all right, then I'll just answer his last question. So yes, Jaggard index has a lot of drawbacks, and you're right in thinking that it has a drawback in being sensitive to word frequencies. But that's why we use the vanilla. We didn't use the vanilla Jaggard index, and we use the modified version, so as to make it less sensitive to the number of words that are present in the string. But yes, that is a drawback, and if you could improve upon the string matching technique, then you would definitely get better results, and that is a future point of discussion that we are looking at. Yeah.
Okay. Thank you. Okay, you got a lot of questions here from Maria. Thank you for the interesting talk. Can you comment on what criteria you use for setting the theoretical criteria for distinguishing not distinct nutritional value of the recipe? Maria's here, so Maria, tell me.
Yeah. Could you elaborate a little bit?
yeah, at a certain point, you say that you use a theoretical criteria to consider that your recipes have the same nutritional value, although you change slightly the ingredient. Did you said that it was a theoretical threshold, but
Oh, are you referencing to the fact that that I mentioned that the nutrition value of recipes can be added up from the values of their ingredients, or?
yes.
Yes, yes. As stated in our paper as well, there was a study done. I'm forgetting the name of the paper, but there was a study done and cited in our paper. So once it's out, I think you'll be able to see it. But so yeah, what they said was there's not a huge error margin in which if you add up the ingredients separately, and if you compute if you send the recipe or the for the food for chemical analysis, there's not a lot of difference between the nutrition calculated that way. So that is what I was trying to articulate.
Okay. But you didn't integrate that in your model.
No, we couldn't. We didn't. So we only use the sum of the ingredients. We couldn't figure out a better way of going around this problem just because we didn't. So we didn't have a lot of training data, but that is in other subtasks that we could do is, so for example, if you have each ingredient's nutrition value, so what you could say is you could just use, I'm just for a purely theoretical point, I'm not going to use linear regression, but just for example, use linear regression on these points like that. You have these values of X and you put a weight on them, and then you get a Y output, which is, and you can train the model on that basis. But for now, we only just added them up, because the study mentioned that it does not vary that much.
Yeah, it's a very challenge question, because even if you use the same ingredients and you process in a different way, you may slightly change the nutritional value.
Yeah, correct. Yield values is also one of the problems with it, because if we could incorporate yield values, that is, before cooking, this is the amount of nutrition that is present in the food, and after doing this process, this is the amount of nutrition that will be present. That will definitely improve the model a lot. So that is also one of the future works that we should be looking at. Correct. Yeah.
Great. Thank you.
Okay. All right. Is Devansh Batra here?
Yeah, he's here. He's joining. He joined just now.
Okay. Yeah. Thanks, Jushan.
Thank you.
Okay. So he's here. Yeah, this was answered already, but I thought I'd put it up there anyway. So I noticed that very low percentages of the total data were used for training and testing. So he basically said this. Yeah, I know it would make it more difficult, but if it was any more, it's still a lot since they had a lot of recipes. But did you want to add anything, Devansh?
Sir, the training and testing set, which
Yeah,
is being talked about over here, here that refers to, for that we require manual labels. This is for the named entity recognition. So we require labels which are accurate to actually train this, and there was no corpus available beforehand. So what we did was we actually, whatever recipes were corrected, first of all, the clustering was done to get the characteristic, like the uh, several different type of individual uh, clusters which had similar, very similar sentence structures. So if we were to label sufficient of these sentence structure from each cluster, so you can assume that the model would be able to learn to actually predict the other sentences which had same sentence structure, that is the other sentences in the same cluster. So we do recognize that we should have more training data, but the clustering helped us a lot, because we could like these would be the these could represent the clusters themselves. So
Okay.
when we say from 1% have been taken, actually 1% have been taken from all of the clusters. So this has actually been explained in the paper when they had a very high rate of F1 score after we apply clustering versus before we apply clustering.
Yes, I'm in a
So
virtual
there is an
conference.
increase in the F1
I
score
really want to
there.
take this call though.
And since we had to manually map, there was a limit to what we could do. Even if you look at this, there were 11 million training
Could
phases.
you please? That would be great.
Yeah, because we're just going to go over the corona screening questions. Do you have any corona
Oh, no,
symptoms
no,
at all?
no, 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 no. No, no, no.
Then you're good. That's all I needed. I was
Okay,
just calling for that
okay.
appointment tomorrow.
Thank
You're
you.
all set.
So one last thing I wanted to point out was while you're looking at the recipes, I would like to look at the words. We had in these recipes, we had 11 million ingredient phrases. So if each of the phrase has 10 words or 6 or 7 words, I don't remember the average right now, but let's assume it is 6, which is like a bare minimum. Even then, there would be 66 million words, 1% of which is still very high, all of which has been manually marked, and they have been checked as well. So in NLP, we consider a corpus to be gold standard if a manual and another manual annotator has given it a check mark that this transition is okay. These annotations are okay. So it is a gold annotation of all of those. Means it has been double checked as well. So clustering plus the gold annotation probably does a trick for us. Is that
Yeah, yeah,
okay?
it's fine. Thank you. Thank you. So is Changwen Shu? Is he around?
Yes, I'm here.
Oh, hi. Okay. So again, this is from me, I guess. So how do you weight process versus ingredients when you do matching? Do you just do half and half, or how do you come up with that?
Sorry, I'm not sure your question means.
You were
Because,
matching recipes that I thought, and
yeah, the recipe, yeah,
but that consists of the ingredients as well as the process
yeah.
of cooking. So do you give a weight to one and a weight to the other that could be different?
Cause like I was abstracting the process and the relative ingredients from the instruction. So generally they are one-to-one. You know, one process, yeah, related to one.
Yeah, people do that, but yeah. But
It's easy to.
yeah. Well, that's what I thought, but sometimes they weight other things, especially, I mean, you're working in high dimensions, I would think. You're doing matching of vectors, I would think.
Oh yeah, I got your questions.
Yeah, so it could have different size dimensions too, you know, and
there are actually two different methods to analyze the similarity in my research. The ingredients similarity and the recipe similarity.
Oh, I see. So you have two separate vectors and you do the matching separately, and then you do an average.
In the ingredient similarity analysis, I don't need to pair them.
Yeah, okay.
But only in the recipe similarity, I need to pair them.
Yes, yes.
Yeah.
Okay.
So the recipe similarity are all based on this pair. So there is no weight problem here. The only text used for the doc2vec is the data of process paired with ingredient.
Okay. Okay. Very good. Thank you.
Mhm.
This is a question that was answered by Pascal. Pascal, are you there?
I'm here, yes.
Okay, okay. So this was answered already during the talk. So I just put it here for a record. Okay. Thank you, Pascal. Trip Sharma, is he here?
Yes, sir. Yes, sir, I'm here.
So you mentioned when you were doing hierarchical clustering and getting a tree that there were no trees available to compare it with, the ground truth.
Yes, sir.
But I was thinking, I've seen many trees of how languages develop and cultures, you know?
Yeah.
And they have phylogenetic trees, and they have all kinds of trees. I'm not saying there's a one-to-one relationship here, there probably isn't. But if two cultures kind of merge, I would think their cuisines merge in a way. And if they break off, maybe, you know, so there could be some similarity there.
Yes, honestly, we didn't think of like there were language trees present there. So I just had a look at one, and I can share the link for that too as well. So you can see the chart. Well, it's kind of a verbose tree, I would say, and it does contain, I believe, a lot of the languages that have been developed so far. But there were some reservations, I would say, because because I would say that, for example, consider Canada. The country has some languages like it's quite diverse, and the languages there would be varying from Punjabi, that is from India, and English, and as well as French language too. So we cannot say that how these different cultures would be merging if based on only based on these languages. However, I feel that if we could find a way to collaborate the geographical based tree distance geographical distance based tree and the language tree, then I believe that we could get somewhere. It could help us, I believe. But I think that we might hit some hindrances while only using the language one. And the geographical distance based model was quite simple, and there was a simple relationship between the vegetation, I would say, and the cooking. So we went with that one.
Okay, yeah, some good ideas. So thank you. I think that's it for that. So how do I stop sharing? I go like this, right? Okay. So you guys can still hear me, right? So
yes.
Okay, so now we're going to do some presentations, short presentations, maybe a few minutes in length for whoever wants to jump in. We have a list. Let's see who is. I can't. Okay, here we go. So let me see here. Alan, do you want to jump in and say a few words?
Sure, happy to. Yeah, Bill asked me to see if I could say something controversial, so let me try that.
I like that.
You know, as I'm looking at the research that was presented today, I think it's excellent, rigorous research. One of the things I'm missing, though, is who are the stakeholders? Who are you doing this research for? In good design research, there is a necessary intervention where you're taking the results of your research and you're improving certain parts of the world. So the research results you're getting, how are you engaging your stakeholders? And that's something I'm sort of missing in a lot of this research. And let me extend that before people start jumping in, and that is the other thing I want to see in good research is sort of setting your goals. I mean, what do you hope to achieve with your research? And how would you measure the achievement of those goals? I'm seeing a lot of statistical work. I'm seeing a lot of empirical data. It doesn't really show me the impact that you want to make in the world with your research. It just looks like a lot of numbers. I'd like to see a little more goal setting that would have sort of a measurable impact on well-defined stakeholders. Okay. So let me just throw that out. I know I'm, come from my mindset of design science research, but I'm hoping that maybe you can think along these lines also and say, how does my research make an impact into the world? And how do I ask the question of why is it making an impact? And how can I build some design theory around my results?
Well, that's very interesting. Most people just, solve problems, as you said. But I do want to point out, and people may want to go into literature, there is a paper, a very nice paper. I mean, I've seen computer cooking at conferences for over 10 years where they had cameras, and I think it was an offshoot of computer vision and multimedia. They wanted to see how people cook, and they kind of analyzed it. But it's morphing into a lot of things now. There's a very nice article that was published in 2019 in ACM Surveys. One of the co-authors is Ramesh Jain from computer vision and events, and now he's into what he calls food computing. And he goes into all these things that you mentioned, actually. There's a lot of things. People's health is one of them. You want people to eat the right food, and you want them to be aware of all this stuff. There's a lot of fluff in it too, I know, but so people are going to wear, these watches or whatever and consult them. So that was one of the questions I had later on. Basically, what do you see for the future? How would people use all these results in a future world where maybe there'd be an appliance that you'd wear and it would tell you all these fantastic things about food and about your health, as a matter of fact, and maybe that you shouldn't be eating certain things, even though you didn't know that the particular thing was an ingredient of another particular dish or whatever.
Right. Well, my key question is, where's your intervention? I mean, you've got some nice results. How are you intervening in a real world environment to make things better?
Oh, yeah. I think a lot of the literature mentions that, the people, but in some of the papers, no, I guess you're right there. But it's basically, so it's called food computing. I think that's the term they want to market now, food computing. And they do go into health a lot here. That's because food is obviously very important to one's health. If you don't eat right, you're not going to be healthy. So that's a big one. But other than that, what we've seen today is very interesting, but it wasn't mentioned. That's probably true, but yeah, I agree. I agree. So, anybody else want to chime in? Anybody else?
If I can add, just a remark to Alan, and it's cool you bring that up. So the stuff, or some of the stuff I'm working on, like the data management piece, right? Kind of improving schema modeling processes, which I presented in the keynote. So one of the problems here we always have is, how on earth are you going to evaluate that? So kind of we understand the stakeholders, we understand the goal, right? And I'm kind of always getting the reverse argument of yours, and they say, give us numbers, give us numbers. So the problem we have in our case is that the methods are designed such that kind of a laboratory setting, kind of, controlling most of the parameters, making a small case study, essentially is by sheer setup such that the methods would not really be effective. So that essentially means in order to show that the reuse of a large-scale model, you know, based on better principles like we believe we have, is really an advantage. One would have to do a large-scale project twice, like whatever, a two-year modeling with the ocean scientists or with the historians, right? But do the whole thing twice and then compare. And you don't find a funding agency who would support that.
Well, that's
right?
called
so it's a catch-22, right?
Yeah.
So.
Well, that's called downstream tags. In NLP, they evaluate things like word-to-vec different approaches by downstream tasks, like you want to do information retrieval with it, or you want to do something else with it. So you're not really evaluating the algorithm per se, you're evaluating how well you can do other things that use your algorithm in a sense. So I think that's what you're talking about.
Well, Pascal,
tricky.
A comment that I had in my talk was this idea of the dancing landscape, in that if you say you need replication, you need, you know, multiple data points, you know, on the same problem, that's almost impossible in good design, because once you put your initial design in place, you've changed the problem.
Yeah.
And so I'm in a lot of discussion with colleagues in our field of information systems, saying we need more replication in our business research. And I'm arguing that's almost a moot point, because it's not clear what replication means in this type of work.
Yeah, I completely get you. Yeah.
So
you should review some of my proposals. They may perhaps fare better then. Thanks, Alan.
Like quantum mechanics, when you observe it, it changes, right? Or something. So.
Yeah, I mean, what I got from people like doing software engineering research, right, is essentially what they've been telling me is the only way to really do this is to make your process look like a lot of small pieces, and then you evaluate each of the small pieces, you know, on a small scale.
Metrics. Do you have any metrics on rules? I mean, software engineering has a lot of metrics on what makes a good module. Do you have any for this area?
Yeah, this is one of the problems, right? We don't really understand the problem well enough yet, right? We can do small scale things like look at, you know, how much time does somebody need to solve a certain modeling task in a reasonable way, but if we give him, you know, better interfaces which are built on our principles. And this makes for good papers. But to be honest, I always have a bit of a bad feeling about whether, you know, we're really controlling the right parameters, right? But that's just how it is. So.
Yeah. Okay, Alan, do you have any more to offer, or
no? I think I've been controversial enough. I'd like to.
Okay, that's good. No.
Comments, Frederick.
Okay, Pascal, you want to throw
out there?
You have anything you want to say, Pascal, besides what you said?
I can let me share my screen. So I can't really say anything controversial about recipes and food science and things like that. But just a topic which we've also been dancing around here, and perhaps some people would say it's not at all controversial, but let's just see. So of course we know deep learning has had fantastic success stories in the last 10 years. So they really solved some tasks we thought were 10 years out or something like this, and that is cool. But at the same time, and in particular, also looking at the talks we heard today, some of them, there is a lot of knowledge representation going on in the sense of structured representation of information, like, for example, the recipe information, food information, nutritional information, all this kind of stuff. So, and at the same time, we're trying to use deep learning systems to solve some of the puzzles here of representation, like classifying things correctly, for example. Now, something like classification of things from whatever data, that is a good example for a problem which, in terms of deep learning, can be addressed pretty well, right? And I would call this learning simple tasks from data. And yeah, I call them simple, although there may be tasks which 10 years earlier or 15 earlier may be impossible using machine learning, but now they are. And they're still relatively simple tasks if you compare them with the complex knowledge representation that is necessary to, for example, feed an information system, right? The stuff you have in your databases and how you organize that. These complex models, or say how you, now going even a step further, how you set all the complex parameters and their interactions in a model of a physical occurrence like weather, for example, or soil erosion. In all of those, a lot of complex expert knowledge actually goes in. Now, what we can learn using deep learning are simple tasks. We can classify stuff, right? Essentially, that's what we can do. Now, on the other hand, deep learning systems are great in dealing with noise. You can disturb what you give them as input. They still work pretty well. If you use an information system, in particular, if it uses some logical reasoning in the background, like expert systems, for example, often do, but for which you also need to model the complex expert knowledge, then they are extremely brittle in that respect, dealing with noise. And learning symbolic representations, complex knowledge is, well, at best hardly working, and certainly way, way away from being as powerful as deep learning currently is. So, and that brings me to a very, very old topic, which kind of, I think is, and that is perhaps the controversial statement I'm trying to make, is completely under-researched and underappreciated. And that is, we need to somehow get these things to combine. We need to combine the learning capabilities and the robustness to noise, which we find on the deep learning side, or generally on the machine learning side, with the transparency and understandability and complexity of expert knowledge representation, which we find in symbolic systems, in symbolic information systems, and logic-based knowledge representation. So this combination is heavily understudied, and I believe that it is also a central issue in trying to tackle some of the larger problems we have to tackle in many fields. Generally, you could look at a pipeline like you see at the bottom of the slide here. What does machine learning do? What does categorization or classification mean? Essentially, it means you find more abstract features in data. But the abstractions you find are still exceedingly simple, like typing, for example. What you want to do is you want to find machine learning methods which can learn complex data, complex representations of complex data. And then at the same time, you want to do that in such a quality that you can feed them into symbolic systems, information systems, probably even systems doing deductive reasoning, such that you can do whatever you may want to do on the expert system side of things. And this pipeline is just completely not working these days. There are a few specific instances where it might be possible, may have been possible to close it, but generally that's a big, big, big gap. And I think it's just a completely underrepresented, underappreciated problem. Okay, let me stop here.
Okay, Jushan, do you want to ask your question?
Yeah, sure. So I was actually wondering if I interpret it correctly. So are you trying to say that maybe graph and maybe graphical structures and applying deep learning models on those structures would give us better results? Or are you saying that both of them are different concepts, unrelated concepts, and one has some pros and one has some other pros, but you can't combine those two?
So I wouldn't say as such that knowledge graphs would provide a major advance. So my perspective for knowledge graphs is that in the world of knowledge representation, knowledge graphs are probably one of the most simple paradigms you can think So it is still mostly very, very straightforwardly represented information. And that's also how it's usually dealt with. So kind of knowledge graphs are often made such that the context information which you can actually store is kind of a second-class citizen, you know, and making those first-class citizens would make things very interesting from knowledge representation perspective, of course. So from that perspective, I don't think that knowledge graphs kind of advance that problem, but in a sense, they provide a laboratory setting because they have they're so simple. So try to get machine learning and knowledge graphs to work for knowledge graphs and the representation level of knowledge graphs. And if you try to work on that, then you find out that it's already difficult enough. So for example, do the type of logical reasoning which the RDF standard does on knowledge graphs. Mimicking that with deep learning systems, one of the pieces of work we have done, it's an archive but not published yet. It's already extremely difficult, right? So that's the role which I see there.
Right.
Okay.
Thank you.
Great. Is there anybody else in the audience that would like to ask a question?
I think Dipansh has asked a question, if you would like to.
Okay.
Hello.
Yes. Hi.
Hi. So I wanted to share like how we are actually going to our stakeholders and well, providing our solutions from our research, actually making our research useful to them. Like this is something what Alan had pointed out in the, and I think he really will be interested in some of this. So I'll share my screen. So like we could have gone about provided a download link to the data set, and we could have provided an analysis and the paper that would have been it. But we did go all the way, and we have given like some kind of a fully featured web app where people can explore our data, make use of it, and they don't need to download and actually go about it. So we thought this could be helpful to some chefs. It could be helpful to some people who work in the healthcare industry, those who are diet conscious, or those who are planning to actually, you know, uh, those who are planning to plan their diets. So like here you could choose an ingredient which you have, and you could actually have something that's made out of the ingredient. Like maybe I want to eat something which involves salmon, so I could just that's something I want to eat today, and there are a ton of recipes which are available, and I could browse through them. Or another thing which I would call is perhaps our X factor here is like we give you a lot of the details about salmon, and which one would be probably more helpful to you. So apparently USDA could not uh, give too many details on salmon, but you would say this would be helpful in other cases where we have results. You could get which one has the least lipid fat and buy that, or the least energy amount or carbohydrate amount or a higher protein amount. So this would be helpful, and then we have provided ways for them to search based on the nutritional content, based on the category of maybe you don't want to eat something that's dairy, or maybe you want to a vegan diet. All of that could be satisfied. You could just search according to this and maybe change a few things, and you will get the results, because we have a ton of recipes, so there are a ton of results. Like uh, this falls within the threshold set by you, and we have information about lacto vegetarian, about the dietary style. So maybe uh, you would like to have something that's
Okay, well, let me jump in and ask you a question here. This is a great tool have you measured how it's been used? I mean, do you have how many people have viewed this? How many people have used it? And have you done any case studies to say, okay, let's see how somebody, say a chef or a nutrition expert, would actually use this in a real world
Yes.
scenario?
Yes. So we have been talking to some chefs who have been using it, and this was featured in the Vogue magazine. I'm not sure if everyone is familiar with it. The Vogue magazine is actually a very famous magazine, at least in India, and I yes, here it is. So it was featured in this article over here. Much of it is paid, so I won't be able to show it to you. I'll put the link in description. And so the people, this was actually by Sonal Ved. She is the dietitian of a very famous Indian actress, Kareena Kapoor. So this is being used, and we have chefs using it. We have some partnerships with chefs where the lab is continuing in several projects.
Okay, very good. I mean, that definitely shows impact of your research. So congratulations.
Something, and we are like continuing on it. We have a few more projects going on. Maybe like this would, this is probably a better way to search for recipes instead of the threshold thing. And I'd say this is just another way to look at it. But what happens if you want to, you have a recipe in mind and you want to see how it will turn out? So what would be the nutritional content? So we have a diet designer over here. You could try that out. So I made some chicken ramen soup, and
It does seem like Alan's comment turned out to be quite controversial. But yeah, so basically we have been making various utilities, and we have been using
pretty
various
much
methods to try and to try and make it usable for the general user. And we'll definitely come back next year and update you, Alan, as to what changes we've made.
how this project goes.
Okay.
And we are lately working on actually generating some novel recipes. I should be able to find some results right away. Just a second.
Okay. Anyone else?
And all of this is based on the model which I had presented in my summary. And the, well, so we have been working with some language models and stuff, and trying to actually, maybe what happens if I start the recipe in some way. I just mix half and half and poppy seed, and what should I do next to maybe get a something I could eat. So that's what we are looking at. And yeah, you can see the results over here. I guess there are some updates which aren't in this file, but this could be useful to people uh, later, in the sense that just encode whatever information you have, whatever you want. We want it to not be just how you started the recipe, but what ingredients you have, or what utensils and ingredients you have in your home, which could be encoded. And probably we could make use of that information and give you a great recipe which you could try it out at home. And we have some updates, but I think it would be better if we waited until this is published later. So yeah, we have been focusing on our stakeholders at risk, and ever since Cozy Labs began, a lot of our work last year here was also focused on flavor DB. Right now it was focused on recipe DB. Again, we could have like provided our findings and gone through with it, but we like to make it usable for the public. We have web servers uh, available. This is also a really nice work. I would recommend to look at it, but I think it might be a little out of scope if I went on here. But yeah, so I'm putting the link in the chat if anyone wants to have a look at.
Okay.
So that's it.
Very good. Okay, thank you. Anyone else in the audience or the presenters? Okay, George, is George around? Frederick.
Yes, I am around,
Okay,
Bill.
yeah, George.
Yeah, I mean, I guess my my interest in the whole area, I mean, in our papers today, we've seen a lot on the rendition side of things, but on the receiving side of things, on the user side of things, we haven't looked at it that much here, you know. So, you know, my interest is, you know, of course, eating is a multi-sensory experience. Okay, even though we talk about taste, which is a monosensorial experience, but then you're thinking about the fact that taste, you know, you can distinguish between, you know, 5 to 7 to 14 different types of tastes, and each taste has different intensities, and each taste, or of course, also has different signals that you can then process, and again you can use to create, to combine tastes and to create even, you know, these weird new combinations of new tastes. And you know, I don't think we look at that enough. You know, I mean, taste. You know, we haven't looked at how one taste masks another, or how one taste can actually complement the other. And even though these things are perhaps better known, I wouldn't say well known, but better known in the non-digital world, for us it's very difficult to translate these things to the digital world. And again, another thing from the human processing side of things, you know, as I said, you know, the experience of eating is not just strictly linked to taste. You know, there's you know, a lot of hidden science. You know, when they say that you see you see what you eat. You eat what you see, in the sense that you know, we eat with our eyes. And you know, there's been you know, lots of work which says that the color of the plate influences the taste of the food that you eat. And again, you know, we don't know how to translate this into digital experiences. And again, you know, there's a lot of potential for taste, and we've touched upon this, to go into therapy, into you know, therapeutic purposes. And again, one of the papers actually did touch upon this in the session today, about how can we combine, how can we make recipes out of new recipes. But I actually go further. You know, how can we, you know, how can we create new weird and wonderful food, which we can't even begin to describe. And here I want to link to, you know, the you know, Pascal and semantics, and the famous cow in Texas example. You know, in the sense that, you know, we're all primed to recognize what is a cow, but if we are sort of shown a weird and wonderful new animal, we're stumped. We don't know how to describe it. Well, you know, if we go and have an analogy with taste and food, if you're showing a picture of a particular, you know, weird and wonderful food creation, and it's not something that we know already, how can we describe that? How does our prior knowledge, our prior priming, enable us to describe that taste and our perceptions of that taste?
Yeah, yeah.
So I guess just to round off, from my point of view, you know, food and digital food, we mustn't forget that it's a subjective experience, okay? And we need to involve humans in it. I mean, it's all very promising that we do a lot of AI, ML, and number crunching on these things. But, you know, food wouldn't be food unless there was a human there somewhere.
Okay. when you talk about seeing something new and completely different, the thing I thought about was what, I don't know if it's popular nowadays, molecular gastronomy. There used to be fancy restaurants that did that. Basically intense flavors, you wouldn't believe it, but it can come from dry ice and a lot of processing or something. There was a famous restaurant in Spain called El Bulli, I think.
Exactly.
It only fit about 10 to 15 people, I think, and you had to call a year ahead to get in, but it was out of this world, supposedly. So, yep. So, Frederick, do you have anything you want to say?
Yes. Let me share my screen, just a moment. So for us, it's more at the crossroad of cooking recipe, computing, data engineering, and citizen science. So two challenges. One is sometimes we don't know what to generate from our fridge food list. So what kind of food we can produce from our fridge in terms of dish generator, but to fit with our taste expectation. That's the citizen, as mentioned, George, is also important because we expect, but it's not only mixing. That means the taste is very important and the flavor, because sometimes we have different expectation and the result is maybe doesn't fit with our request or expectation. And then the second challenge is a cooking recipe optimization when we want to improve, like for example, the processing times, reducing the number of calories with ingredient of replacement to improve some allergy, testing issue, cost, and so on. So some constraint processing. And with cooking execution plan, for example, how to deal with both optimization and constraint. That's our some challenge we are dealing with. Thank you.
Okay. Yeah. So is there a time, or do we have to be at it exactly 5:30?
No, you can conclude.
Okay, well, conclude, I don't know, but...
Thank you for your inspiration.
Yeah, thanks. So I'm going to share my screen, just say a few words. Okay, why doesn't it share? Oh, I know why. Okay. I think I know why. Let's see. All right, here we go. Recipes, meat, where is it? Here we go. So that's the title of our workshop, Recipes Meet Data Engineering. But basically, this field reminds me when I was young, and I was on the early days of what was called content-based retrieval, multimedia in the mid-90s, specifically 93, 94. And I could say almost the same thing about that I can say about this area, only this area is much more rich. I noticed some people said they never did work in this area, but if you did work in any of these things, I mean, the enabling technologies behind this area, you could say that you've done something. So I find, database and data modeling and how you model entities and temporal processes together is very important. I remember back in the old days when I attended a workshop with Michael Stonebreaker, and there were about 100 people there from content-based retrieval of multimedia like images and video. And we basically all believed the current database technology was not good enough. And he was one of the few people there that said it was. And we kind of ganged up on him and whatever. But basically, it's not so obvious. I mean, we need new querying modalities and indexing. I was in on the early days of bringing kind of databases to signal-based processes and having that technology available for answering queries. So data modeling is important, and temporality. So you have processes of cooking, it's temporal. and then you have ingredients. And how do you do indexing in these kinds of affairs? So that's very important. And then there's content-based recognition techniques from computer vision and multimedia. I mean, if you see a picture of food, how the heck do you analyze it? Okay, deep learning is used a lot here. Food-based embeddings comes from NLP, natural language processing. I mean, the first paper in that area was in 2005, and Mikolov discovered an efficient way of doing it in 2012, 2013. And all of a sudden, people are using it. I mean, in 1994, I tried to look ahead. I couldn't believe what's happening now. Who would have thought, you know, almost 25 years ago, basically it's almost 25 years ago, that we could do such things. I use WordNet a lot for various things in NLP. So what about a WordNet of food? I think some people are looking into that already. I remember reading. So instead of words having synonyms, maybe you have ingredients that can be substituted for each other. They're synonyms of each other. So you can, and other relationships.
Well, net of
carbon
carbon footprint
analysis as well. What do people say about food, and how do you interpret that? If they like it, they don't like it. Recommender systems. You want to recommend some kind of food based on what other people are doing. So George mentioned taste or flavor, was also mentioned by one of the presenters. So yeah, so here are the 5 basic tastes, and there's more that goes around it. So I remember, this is kind of like content-based recognition in the old days, about, you know, you have a signal, you have a video signal, you have some kind of signal, speech recognition. Basically, how do you do these kinds of things? Right now, they're measured by your brain state, and I think they know where each individual taste lies in your brain, basically. And I think there's a linear scale for each one of these. But basically, you know, salty, sweet, bitter, sour, and umami, which is called savory. And there's something else called richness, having to do with fatty foods. Okay? So basically, and types of data, it's not just recipes. And one thing I do want to mention, a recipe is a short document. Through a lot of experimentation, we've realized that Word2Vec and a lot of other techniques don't work as well with small documents. The documents have to be like medium sized, at least 1,000 words to actually get anywhere. There are lots of testing sets out there that are like Reuters newspaper clippings. They're very short, and a lot of techniques will not work on these short documents. So what do you do about that? I think menus are important too. I don't know if anybody's mentioned menus. Maybe they have. I think there's a lot of annotation that goes around with a menu when they cluster dishes together. It might be important. News stories too. NLP is a very important component of this. Now, the data is ubiquitous. It's spatial, it's temporal, it's all different kinds mixed together. And then you have effects on the brain, like flavor is mental, illness is physical, nutrients for health is physical. So all these things are in this area, and how they can all be combined into one thing, that's for the future to decide. So that's all I have to say about that. Anybody else want to chime in? Anybody in the audience have any questions? Because I think it's 5:34 and it's probably time to go, but if anybody wants to ask some questions of anyone here.
Ocean, just share a resource about WordNet on food.
Yeah. Oh, okay. Yeah, I do remember reading an article on that. Yeah, but so Jushan?
Orshani?
Oh.
I don't know.
Yes, hi. I just wanted to share that resource with everybody
yeah, if you could,
in this workshop.
That would be great.
It's already in the chat box.
Yes.
Okay. Now, do you have the results of the Best Paper Award by any chance?
Yeah, I do.
Okay.
We can, I don't know if someone wants to say anything else.
Yeah.
Yes.
Otherwise,
So thank you for this panel discussion session. Thank you so much, Professor. And thank you for all the participants and inspiring discussion. Thank you.
and if you want to any resources that was shared and you miss it, you can always shoot us an email and we will try to get the resource to you. So next is the Best Paper Award, and we are happy to announce.
Yes, may I share?
Yeah, I was sharing.
Yes.
Or you can share. Yeah, it's better. Can you share it, please?
Yes. Okay.
So we are pleased to announce that can you move the next slide, please? The best paper was awarded to food recipe alternation and generation with the natural language process techniques from the authors Yampan, Q-Chu, and Wei Lin, Fudan University. Congratulations.
Thank you. Thank you.
And we will, the award is the certificate. We will sign it and send it the hard copy by email or mail. Yeah.
Postal mail. Yes.
Yeah. And the other, what comes with the certificate is the free entrance for the next DECOR, DECOR 2021. So you are welcome to join us, and you will have the coverage of the registration fee is part of the award. Thank you so much for all your participations. We have wonderful talks, and it's always hard to select the best one because we would like to have more, but congratulations.
Yeah. Thank you.
Thank you. Thank you.
Oh.
You can, yeah, please, if you have something to say, please choose.
It's very glad to have this award. You know, and it's quite a tough time for me to start to keep working on academic researches. You know, everybody is separately staying at home, and it's tough to like have teamwork on certain projects. So it's really not easy to finish those research. And I hope everybody can keep on working on the project you are interested in and keep fighting for it. Thank you, everybody.
Thank you. Thank you.
Welcome.
Yeah, congratulations. Yes, our pleasure.
And now I leave the word to Frederick Andres, please.
Yes. Yes, the closing segment. So we were, we completed our third international workshop DECOR 2020, where we saw that a new way of food inspiration, combining ingredients and the way to match cultural culture with food computing. And so it's interesting how the culture can impact the data engineering and the way to fit with new direction of research. I would like to thank you, the co-chair, my co-chair of this, my friend and co-chair of this workshop, Professor William Groski, Professor George Guinea, and Dr. Maria Lecce. It was a great pleasure and even if we had a lot of work this year, and we were very happy. Unfortunately, we couldn't be in Dallas, but maybe it will happen in the future. And thanks to NII, we will have a coming call, and we will distribute to all attendees a call for participation in a coming flavor-length DECOR Challenge 2020. It was initially aligned with the Olympic game, but Olympic game will be next year, so we will see how we will promote this event. Then we would like to thank a lot several supporter and help in the data engineering conference. So the general chair, Professor Vanani Turazenham from University of Texas at Dallas.
Thank you, I'm here. I found this workshop excellent. I was listening to the second part. First half, I was at the blockchain, and I really found it very, very useful, your workshop. Thank you so much.
Thank you for your support and inspiration.
Thanks.
We hope to be in Dallas soon. I don't know if you will, you know, Japan just moved off 1 year Olympic Games. So maybe Dallas would be able to, I don't know if it will be would be able to host 2021, maybe again, real data engineering. I don't know if it's a plan, but it could be great.
Yeah, we don't know. We have to talk to the ICD steering committee and the technical committee. Thank you.
Yes, thank you. So, Professor, we would like to thank Professor Elena Ferrari from University of Izubria and Professor Rao Kotagiri from University of Melbourne for their support. Of course, our ICD workshop chairs, Professor Mohamed Mokbel from Qatar Computing Research Institute and Professor Chris Clifton from Purdue, who supported a lot in the last few days and even before for organizing and scheduling and all this online organization, because it's amazing how we could have a good quality and a lot of very interaction and so on. Of course, our keynote speaker this morning, Professor Alan Avner from University of South Florida, Tampa in USA, and Professor Pascal Isler, Director of the KITES, Kansas State University. And we should not forget our student volunteer, Mustafa, Yen, Damian, Gabriel, who especially from Japan, who had this all-night support for this workshop, because we started at 11 p.m. and we finished at 7 a.m. this morning. So it was a great pizza and the workshop party all night supporting this amazing inspirational workshop. And of course, thanks to our author, 21 authors this year, PC member and steering committee, participant, and our support, NII, Brunel University, University of Michigan, Den Board, and University of South Florida, St. Petersburg support, and my mother, who passed away, but who inspired our project on food and cooking. Thank you so much, and see you next year soon. Thank you.
Thank you, Frederick. Thank you.
We should be able to clap.
Yes, we have. We produce.
Maria.
Yeah.
Are there multiple campuses at University of South Florida?
Yeah.
Where's the other one?
3.
I'm in Tampa. Maria's in St. Pete, and there's
St. Petersburg.
And the third one is where?
Sarasota.
Oh, is that on the west as well?
Yes.
Oh, I thought it was close to Miami somehow.
Oh no, Sarasota's on the west coast.
Yeah, that I know, but I thought South Florida was close to Miami. Oh well, I'm wrong.
So actually, South Florida is about 300 miles from Miami.
Okay.
Yes.
Yeah, 300. Yeah, it takes about, I think about 5-hour drive, right? 4-5 hours.
Oh yeah.
Yeah.
At least.
Thank you for the